let's just get plugged in.
Wow.
What do you mean?
Well, how did you
Because it looks. All right. Let's see. What are we doing here? Okay, going over some of these. First off, I want to say to everybody, including the guys who are live streaming for tomorrow's test, if you're taking it in person, the way that I'll be doing this is I will be in here with the tests. If you want to start taking it at 8:30, great. Show up then, and then you can sit here. I'll give you your test. You can start taking it. You'll have until 9:30. So if you get here late, that'll decrease the time that you have. If you get here early, it can increase the time you have up to a total of 1 hour. So if you're on time, great. That'll help you out. If you're early, even better. We can get started early. Okay, so how about please, your textbook's open to page 35 for problem set 7. How about the homeworks? So we can go over some of these problems. Remember, test tomorrow will cover lessons 1, 2, 3, and 4. So one of the things that you might have noticed, but if you haven't, I'll point it out, is that in the problem set in the textbook, underneath the number of each problem is a little number, or sometimes 2 numbers in parentheses. That's what lesson that problem is based on. So if you want to make sure that you're ready for the test, look for the ones that have a 1, 2, 3, or 4 underneath them and make sure you can do all of those. All right, which ones do people want to go over?
14.
14, all right. 14. Let's make sure we copy it correctly. Negative, parenthesis, -3, close parenthesis, minus, bracket, negative, parenthesis, -4, close parenthesis, close bracket, minus 2 plus 7. Okay. What should we do here?
Simplify it.
How are we going to simplify it?
By making it negative or positive.
By making what?
Well, you gotta add up the minus.
3 positive, so positive 3.
Okay, so first off, we have -3. How could we rewrite that? Positive 3, just 3. Okay. What else?
-4.
Where?
-4.
Here?
Yeah.
Right, because it's minus -4. We've got 3 minuses, 3 negatives, so they'll combine to still be negative. So -4 or plus -4. Instead of writing -2, what can we write?
-2.
Plus -2 plus 7. Then I recommend combine the negative numbers, combine the positive numbers. So we combine our negative numbers, we get what?
6. -6.
-6 plus
10.
10 equals
4.
4, positive 4. So make sure that you are canceling out your negatives properly. If there are an even number of negatives, including 0, then the whole thing will be positive. If there are an odd number of negatives, then it'll be negative. So minus -4, we can also think of that as plus -4. And so 2 of these negatives will cancel out, and we're left with plus -2. The other thing that I recommend getting in the habit of doing, although you don't have to do it for this problem certainly, is instead of writing -2, we write plus -2. Because adding negatives, I think in general, will help you out in this class. Adding negatives instead of subtracting positives. Questions about that one or another one anyone wants to go over? Guys who are watching the live stream, you can write in with ones you want to go over. Yes?
8.
Number 8.
No, 18.
Sorry, 18, yes. 18, all right. Similar type of problem. -3 minus, parenthesis, -3, close parenthesis, plus, pipe, -3, pipe. All right. Simplify this, what can we do?
-3 plus +3 plus 3.
How did you get those? So the negative 3, obviously that stayed the same. How did you get plus 3 here?
Minus negative.
Right, we're subtracting a negative. These two negative signs cancel each other out. We're adding a positive. And then what about this last one?
Is
What do these pipes mean?
that opposite.
Not opposite.
Um,
Well, what do? What do they always do to the thing inside?
they make it.
They always make it positive. Right, this is for absolute value. Let's take the absolute value of the thing inside. Or you can think of it as whatever's inside, just make it positive if it isn't already positive. So negative 3 becomes 3. The other thing to remember about these, and this might have come up on one of these problems. Yeah, so number 20, for example. Let's do number 20. Because I think a demonstration of it will be better than my just explaining. We've got negative, pipe, negative 3, minus 2, pipe, minus, parenthesis, negative 3, close parenthesis, minus 2, minus 5. For this problem here, when we simplify it, what simplifications can we make?
Negative 5 minus, no, negative 5 plus 3 plus
Plus negative 2, plus negative 5, right?
yeah.
Okay, now you got that correct for the first one, but I want to go through how we get that. So we've got negative pipe, negative 3 minus 2 pipe. What do we do first here to simplify this first part of this problem?
Negative 3 plus negative 2.
Right, so we can think of this as negative 3 plus negative 2, and that's the thing we do first. The pipes not only tell us to take the absolute value of this, they also count as parentheses. So we have to do whatever's inside them first. So we've got negative, and then negative 3 plus negative 2 gives us what?
Negative 3, negative 5.
Gives us negative 5. Now, be careful because you might see, oh, there's 2 negatives that makes it positive. But no.
Gotta make it positive.
Because the absolute value sign there means take whatever's in here and make it positive. So we've got negative 5 plus 3 plus negative 2 plus negative 5. That absolute value sign just got rid of this negative sign here. And the other one's still around. So we've got negative 5 plus 3 plus negative 2 plus negative 5. We end up with a total of what?
Negative 7.
Negative what? Well, negative 5 and 3 will give us what?
Negative 8 in all.
Mm,
Winner. Negative 9.
yeah, negative 9, right. Because negative 5 and 3 will give us negative 2. Negative 2, negative 5 gives us negative 7. That gives us negative 9. Okay. Got to remember that about your pipe stressful value. Any other problems from this lesson that you want to go over? Yes.
Where is it? 12.
Number 12. Positive 7 minus parenthesis negative 3. Good. Yeah. Close parenthesis plus parenthesis negative 2 close parenthesis. All right. So what do we do here?
Oh, 7 plus 3 plus negative 2.
Yeah, 7 plus 3 plus negative 2. Positive 7 is the same thing as 7. Minus negative 3, or we can think of it as plus negative negative 3. Those negatives cancel out, so it's plus 3, and then plus negative 2. What do we get? 7 plus 3 is?
And
Plus negative 2 is? 8. Yep. All right. There's your answer for 12. Other questions? Other ones you want to go over, including guys watching the live stream. I see that you're watching. Hello, good morning. But
27.
okay, 27. Yes, now 27, let's pay close attention to this one because this is, notice it's from lesson 4, so this is a type of problem that you might see on the test tomorrow. All right, in 27, we have 4 1/4 divided by 3 2/5. So we're dividing two mixed numbers. What are we going to have to do in order to divide two mixed numbers?
Denominator times the mixed number plus the numerator.
Right, we'll have to convert them each into an improper fraction by taking the denominator, multiplying it by the whole part, and then adding the numerator. So what is 4 1/4 going to become?
17 over 4.
17 over 4, yep. And then what does 3 2/5 become?
17 over 5.
17 over 5. Okay, now instead of dividing mixed numbers, we're dividing fractions. How do we divide fractions? 3 words. To divide fractions,
Add,
what am I going to say? Not add.
multiply.
So dividing fractions, make sure you know this.
What is it like?
Flip it over.
Keep,
Oh,
change, flip. Keep, change, flip for dividing fractions.
Wait, which one are you supposed to, because depending on which one you flip, is a different answer.
Yes, you do them in order, from left to right. Keep, so we keep 17 over 4. Division becomes multiplication, and then 17 over 5 we flip becomes
5 over 17.
5 over 17. Okay, now to multiply, now it's multiplying fractions. How do we multiply fractions? Go straight across the top and straight across the bottom, but we should check if we can simplify first. What can we simplify here?
17, 17.
17 and 17. So they both become what?
5 over 1 and 1 over 4.
Yeah, they both become 1, because we can divide them both by 17. We're doing the same thing to the top and to the bottom. We're dividing the top by 17 and the bottom by 17. We're allowed to do that because it's keeping it balanced. We're doing the same thing to the top of the fraction as the bottom. All right, so we multiply across the top. 1 times 5 is?
5,
4 times 1 is?
4.
Yeah, so you can leave your answer as 5/4. You can leave it as an improper fraction, that's fine. If you were going to change it to a mixed number, what would it become as a mixed number? 1 1/4, right. Either one of those is fine. So if you got 5/4, great, that's correct. And you can leave it as a mixed number. Sorry, it's an improper fraction. Or a mixed number, either one is fine. You don't simplify, like if you left those 17s in there, if you did 17 times 5 on the top and 4 times 17 on the bottom, and then you didn't simplify it after that, you'd lose a little bit of credit for not simplifying. But mixed number is fine, improper fraction is fine. Either
On the test, will be fine too?
Yep. Yep. I do want simplification, but I don't care about mixed numbers or improper fractions.
Also another question.
Yep.
On the test, so for let's say number 23,
Okay.
I put 5 into it, like, I multiplied by it, and
Okay.
I got that in.
That's fine. So you should have gotten 51.12 yards. Okay, that's fine also. You could do that on the test. I recommend that you don't because then you save yourself the effort of the multiplication and the addition. But yes, I'll take that also.
but if you get the multiplication wrong,
If you get the multiplication wrong, you'll lose some credit, which is
the answer to 182. I did that one.
22 is 224 yards if you did that one. Yep. Yeah. But yeah, so for 23, either 26 plus 8 pi yards or 51 plus 1.12 yards. Either one is fine for the test. But I think leaving pi in is easier, personally. All right, next. Any problems from the homework anyone wants to go over? Covered a fair number of them. There's not a whole lot on this first test. Take a look back to these first 4 lessons. Some of them are kind of long. The first lesson, we're really just talking mostly about adding and subtracting fractions. Second lesson, I'm just flipping through the pages here. Second lesson covers all of these geometrical concepts. Intersecting lines, parallel lines, different types of angles, what a polygon is, what it means to have a concave or convex polygon, a regular polygon as opposed to an equilateral or equiangular polygon. Make sure you're studying these terms. That'd be a good thing to actually study, is the stuff in chapter 2, and I think 4 is the other one. 4 is the other one that's really long. It has a lot of different terms. Also in 2, we get the different types of triangles. We can distinguish them by their sides. We can have equilateral triangle, all sides the same. We got an isosceles triangle with 2 sides the same, or scalene, where they're all different. We could also talk about triangles in terms of their angles. They could be acute, right, or obtuse. What else do we have in problem set 2? We talked about quadrilaterals. There are 5 different types of quadrilaterals you should be familiar with. You can see them on page 8. On page 8, we've got 5 different types of quadrilaterals. A parallelogram has 2 sets of parallel sides. A trapezoid has only 1 set of parallel sides. A rectangle is a parallelogram. It has 2 sets of parallel sides, but in addition to both sets of sides being parallel, all the angles are right angles, so it's an equiangular quadrilateral. A rhombus is what? Look at the picture of the rhombus. Equilateral, right? A rhombus is any quadrilateral, any 4-sided polygon where all the sides are the same length. It's an equilateral quadrilateral. And then a square is a what? Is a regular quadrilateral. So it's both equiangular, all the angles are the same, and equilateral, all the sides are the same length. Also remember about triangles that all the interior angles of a triangle will add up to how many degrees? How many degrees every single time?
180.
Always 180. Always, always, always. So they can give you, like you see on page 8 with those practice problems, they can give you a triangle and tell you the angles, and you should be able to figure out the third angle. The other thing you should be able to do with a triangle is know the relationship between the angles and the size of the angles and the length of the side. Opposite from them. They're the same. This one's a different length because this angle is different. But since these 2 angles have the same measure, these 2 sides are the same length, and vice versa. So for a triangle, if all the angles are the same, if it's equiangular, it's also got to be equilateral for triangles. Those 2 can't be separated, because if the angles are the same, then the sides across from them are also the same. One last thing about that is if we've got angles of different sizes, let me draw a different triangle. Let me draw this triangle. If the angles are different sizes, what can we tell about the relative size of the side? So here's the smallest angle. So what can we say about the side that's opposite the smallest angle? This is the smallest of the 3 angles of the triangle. What can we say about this side?
It's bigger than the smallest.
What can we say about this side? In terms of this
It's greater than 90.
No, this angle
It is
here.
90.
No, this angle here
It's the smallest.
is the smallest angle. What can we say about this side?
That's the same.
It's the smallest side. If the angle is smaller than another angle, then the side across it is smaller than the side across that other angle. So the smallest angle here is this one. So the shortest side is the one opposite it. The largest angle in this triangle is what? Which one?
The one with
90.
The right angle, the 90-degree angle. So which side is the longest? The one across from that. And then this is the medium size angle, and so we've got the medium length side across from it. That's always the case with triangles. Okay, then in lesson 3, starting on page 10, we introduced perimeter, the measurement around a shape. We talked about the perimeter of polygons, but also the perimeter of a circle. What do we call the perimeter of a circle? The circumference is a special term for it. 2 other important, well, actually 3 important things to know about circles. So every circle has a center, and then all the points of the circle are the same distance from the center. That's the definition of it. What do we call this distance from the center to the edge of it? Right, this is the radius. And then if we take 2 radii going all the way across, then we have what? The diameter. Okay. Similar to the way that triangles, their angles always add up to 100 degrees. That's just always a fact about the way the triangles work. Circles have another great fact about them, which is that the diameter and the circumference, the measurement all the way around, always have a particular relationship. The circumference is always how many times bigger than the diameter?
Oh, diameter.
How many times bigger than the diameter is the circumference?
Pi.
Pi. That's what pi means. That number, 3.14159, etc. That number is how many times bigger the circumference is than the diameter. You need to use this many of the diameter of a circle to go all the way around it every single time. Any circle. That's always the case.
So it's usually like a little bit.
Well, that's a little over triple.
Okay.
Yeah, so if you have there's a round lake that's a mile across, then you know that to walk all the way around it's going to be a little over 3 miles. If it's 2 miles across, it's going to be a little over 6 miles to go all the way around. It's always the case with circles. And that's why that formula is this. Circumference equals pi times diameter. Or we could say 2 pi r, because the radius is just 2 times the diameter. 2r is the same as saying d. That's why that formula works, because that relationship is always the same. Okay, then we talked about finding the perimeter of more complicated shapes, where maybe some of the sides are curved. They're parts of circles. And so you'll find the perimeter of whatever that circle is based on its radius or diameter. And then if it's only half the circle, then you'll only have half of it. Right, so like one of these shapes, my board is getting really crowded here. So like one of these guys. Right, so we've got these 3 straight sides, and then this one is half of a circle, so the length of this section here will be half of the circumference of that circle. Then, yep.
The circumference of that pond would be 1,558.32.
Which one? Which pond?
If it's a mile around.
It'd be 1,000 what?
You're talking about the example that you gave.
Oh, it would be a little over 15,000 feet.
Yeah, okay.
Yeah. Yep. Because the mile's 5,280.
Wait, so it just changes into feet? Is that like, oh wait,
If we're doing it in feet. But so if it's 1 mile across, then all the way around is 3.14159 miles to go all the way around. If it's 1 foot across, then it's that many feet. If it's 1 meter across, then it's that many meters. That's always the relationship between the diameter of a circle and the distance around it. Yep.
So that little space that's in between the 3 diameters of the circle to get circumference, what is that space?
0.141592653589979, etc. diameters. It's about 1/7. Right? We can also talk about pi. We say that it's about 22/7. 22/7 is 3 1/7.
Wait, so if you wanted to, could I times the diameter by 22 or?
Yeah.
Really?
Yep.
And I would get the same answer.
Well, approximately. These two numbers are not exactly the same. 22/7 is an approximation of pi, just like this is an approximation of pi. You can't use pi exactly, practically speaking, because it goes on forever and the digits don't repeat.
Wait, who created pi? Why did they create it?
God created pi. Pi is just a fact about the way that the universe
So
works.
who like passed the design?
Who figured it out? This is actually a fairly early discovery, I think. I'm pretty sure, I've got this great book at home which talks about mathematics in the ancient world. And I don't mean like Greece and Rome 2,000 years ago ancient, I mean like Babylonia, like 4,000 years ago ancient, where they're writing in cuneiform. And one of the things that they did was they would calculate out, you know, as many digits of pi as they could to get more precise measurements. But this relationship was discovered pretty quickly.
So does anyone know like the full number of pi?
No, because it doesn't have an end. There have been computers that have calculated it out to probably millions of places, but it doesn't ever repeat. So there's no simple way to write it. That's why we use this symbol for it. It's a type of number called an irrational number. That's a term you'll have to learn later in the year. And an irrational number is a number that you can't write as either a decimal or a fraction. It's a real number. It expresses a real distance. Anytime we have a circle, pi is right there staring us in the face, pretty much. But it's not a rational number. There's no way for us to write it out. And then there are a lot of irrational numbers. There are more irrational numbers than there are rational numbers. Have pi?
Yeah.
We should have pi sometime. That'd be good.
Yeah.
So, I mean, there is Pi Day, which is March 14th, right? Because it's March 14th is Pi Day. So
I never realized.
Yeah.
it was cool when it was March 14th, 2015. At 9:26 and 53 seconds. I actually took a screenshot on my computer at that moment.
Really?
Yeah, because it's, yeah. 3.141592653. That's a lot of digits of pi there.
How much does pi have?
3.141592653588979. That's all. But I had a friend in high school who memorized like 100 digits. He would rattle them off really quickly and you couldn't understand them. He would just sort of mumble them through. So I'm not convinced that he actually memorized all of them. But maybe he did. I don't know.
Peter saying all of the 2 states in like 2 seconds.
Did you do that? All right, so lesson 4 reviews a lot of stuff about numbers. We talked about this distinction between numerals, being the symbols that we use, and numbers. So pi, I think, is a good example of that. This Greek letter, pi, it's the Greek version of p, is a symbol for this number. We can't even write out pi the way that we normally write out numbers. But it is. We talked about real numbers, which is any number that can be used to describe a what?
Integer.
Well, integers are one type of real number, but they're not the only real numbers. You don't need to know about integers for tomorrow's test, because that's in, I don't know, 5 or 6.
Whole number.
So a real number, so a natural or a counting number, remember 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. Those are your natural numbers. When we talk about real numbers, real numbers are any number that can describe a distance. So this includes 0. It includes negative numbers because it could be a distance backwards. And it also includes numbers that have fractions or decimals in them. 3.5, that's a distance, 3.5 miles. Pi is a distance, as we see, even though I can't even write it out as a fraction or a decimal. That's also a real number. Every number we're dealing with in this class is a real number. We're not going to deal with any imaginary numbers in this class. Those are the other type of numbers besides real numbers. Okay, real numbers means the numbers that are not imaginary numbers. Okay,
Wait, it's an actual thing.
imaginary numbers, yeah. So is this? So what's 3 squared? 9, right? What's -3 squared? Not -9, because remember square
Oh, yeah.
that is -3 times -3, so it's
9.
it's also 9. Okay. What's the square root of 9? 3. What's the square root of -9?
No.
-3 is also a square root of 9. There are 2 square roots of 9, 3 and -3. What's the square root of -9? What number can we multiply by itself to get -9?
Yeah.
You can't, because if it's positive, 2 positives multiplied together give you a positive number. 2 negatives multiplied together give you a negative number. This is an imaginary number. 3i. I meaning the imaginary part of it. And I is defined as the square root of -1. Those are imaginary numbers. You don't have to worry about them for this class, or probably any other class you're going to take in high school.
Wait, is there a calculator?
Yes.
Like, what comes after this
After this is geometry.
one? And then-
No, or algebra 2. Which one is it? I don't even remember. Algebra 2 and then geometry.
What? Oh, I know this.
Don't you normally take
And then what is
geometry then algebra?
And then what?
What is in 12th grade?
12th grade. So the normal sequence I think is algebra 1, algebra 2, geometry, pre-calc, and then calculus. So
You did some pre-calc in 12th grade.
I like calculus. I think it's really useful.
Who's he?
It's very beautiful. I don't know who's teaching it this year. Okay. Anyway, so and then we talked a little bit more about the number line in lesson 4, multiplying and dividing fractions, which we went over today. The equal sign and the not equal sign. There's a quick review of addition, subtraction, multiplication, and division. How to add, subtract, multiply, and divide decimals. That might be a good thing to make sure you know how to do. Unit multipliers for converting lengths was the last thing. Anything else that anyone wants to go over?
Oh, no.
I'm also going to have virtual office hours today using the Google Hangouts link on Jupiter Grades. Please feel free to stop by and ask me questions. Go over any of the stuff before tomorrow's test. But otherwise, study, get your work done, get your rest, and we'll talk later.
I'll see you tomorrow.
All right. Yeah, we'll see you tomorrow.
Oh, possible.